from this experience. I'd like to thank everyone that's here once more, and I want us to obviously continue. Welcome, Nigiwe. Thank you so much for joining us. I see Tyrone is also here. Kiandra is also here. Thank you so much. These are people that are almost here all the time. We truly appreciate it. Let us spread the word out there and let's have as many people joining us as possible. I'm waving at everyone. Thank you so much for joining us. I truly appreciate it. Again, this is Natural Science, grade 7. My name is Mr. Alex Songo. Ladies and gentlemen, as we move on, I want us to focus on Malose. How are you? Are you good? Hello, Malose. Good to see you again today, Malose. Thank you so much. All right. As per usual, ladies and gentlemen, we usually give you an activity at the end of the lesson, an activity that is meant to say, or rather to show us or to test how far we understood the previous lesson. So an activity will come in the form of a homework that will be at the end of this lesson. The activity that we gave people yesterday, we gave people substances, number A, B, C, and D on the left. That's lemon juice, vinegar, water, and soap, all respectively. And we said, let us investigate whether these are acids, bases, or neutrals. Number 1, I want to see if I can access the chat box so that I can see if we got those answers correct. I don't know what's going on with my computer. I'm not accessing the chat box. All right. Ranzu, welcome again. Thank you so much for joining us. All right, it's fine. I will try and see if we can get it as we go on in the lesson. So number 1, lemon juice. Is lemon juice sour or bitter? Ladies and gentlemen, lemon juice is actually sour. When we feel sour because we taste it, and let us remember and recall from the previous activity on Tuesday, we spoke about the tongue and we spoke about the taste buds, and we said taste buds are found on the sides of our tongue, at the top, and of course underneath. And we spoke about the taste areas that speaks to the sourness, the sweetness in all the areas of our tongues. I see the chat box is back. Hello, Kiandra, sorry. Tyrone is also here. Thank you so much. There are no questions yet. All right. Let me just put this on the side. Okay. So when you taste lemon juice, it's sour. When you feel it with your hands, it feels quite rough. And as a result, because of its sourness and because of its roughness in feel, it therefore qualifies as an acid. Ladies and gentlemen, I'm assuming that all of us got that correct. Remember, we spoke about indicators and we spoke about blue and red litmus papers. And we said a red litmus paper, if it's put, for an example, in lemon juice, it will remain red because it's indicating to you that lemon juice is an acid. And then we said, if you take a blue litmus paper and you put it in an acid, it will change from blue to red to indicate to yourselves that lemon is in fact an acid. All right, ladies and gentlemen, I hope you understand that. So red litmus paper remains red in acid, blue litmus paper changes to red in acid, all indicating to us that whatever substance, and I'm using an example of lemon juice, will be an acid. Ladies and gentlemen, I hope you remember that. We did that yesterday. We go to the second substance, which is vinegar. Now, vinegar. How is vinegar, ladies and gentlemen, in terms of taste? I see the chat box. Let me have a look. Welcome, Khumuto. Welcome, Obake. Thank you so much for joining us today. Oh, Kiandra wasn't here yesterday. She wants the link to the YouTube lesson for yesterday. Kiandra and everybody else that might have the similar concern or wants to ask a similar question. Ladies and gentlemen, remember you can access us at African Team Geeks. This is on Facebook, and this is also found on YouTube, on the YouTube channel, of course. And as you browse through the videos, you will find the natural science video. Of course, also on the website, www.africanteamgeeks.co.za. I'm assuming that is assisting you. Bonolo. Bonolo is asking if we must have tasted the soap. Bonolo, I had responded earlier and I said we would rather not taste the soap because obviously it's soap, but very difficult question. I would advise that you do not taste it. Thank you so much, Kiandra. I am happy that you understand that you can find previous lessons on YouTube, on Facebook, as well as on the African Teen Geeks website. Ladies and gentlemen, let us continue. Well done. Bella is already giving us the answer. Thank you so much, Bella. I'm concerned about your spelling of vinegar, though. It's not correct. Let's have a look at the one that's showing on the screen. But vinegar definitely tastes sour, vinegar is rough in terms of feel, and therefore vinegar qualifies as an acid. Well done, well done, well done, and thank you so much, Bella, for your response. Now let's go to water on number C. Okay, what is the answer for water number C? I'm trying to look. I see no one is responding to water. A lot of people are responding to the soap. We'll get there, ladies and gentlemen. Please excuse me. All right. So water does not taste bitter, nor does it taste sour, ladies and gentlemen. I am drinking water right now. I just did an experiment myself. Water is what a lot of people might say is actually tasteless, meaning that it does not have any taste. You can also do an experiment of yourself and see. However, is water slippery or rough in terms of feel? Ladies and gentlemen, water is quite slippery. That is why if you pour water on the floor and you are running, you are likely to fall. And God forbid you don't hurt yourself. So water is slippery. However, ladies and gentlemen, is water therefore an acid, a base, or a neutral? Water is an example of a neutral. Let's use an example again of the litmus papers for Kiandra and everybody else that was not here yesterday. Bella, thank you so much. That is the correct answer. Water is definitely slippery in terms of feel. If you take red litmus paper and you put it in this water that I'm actually drinking now, the red litmus paper will not change color. If you take blue litmus paper and put it again in this bottle of water, blue litmus paper will also not change its color. Now, that reason is because it is a neutral substance, therefore it is not acidic, nor is it basic, and therefore the red and the blue litmus paper will not react and there will be no color that will be changing. Kiandra, I see you're asking a question. Okay, Kiandra is asking why is it that she can only speak to me and not everybody else. Kiandra, unfortunately, because of safety measures and also to avoid disruptions, we have disabled the chats between learners and anyone else that's joining our lesson, because people tend to be vulgar, they tend to be rude, and therefore it derails the entire lesson because people start having arguments, etc. So unfortunately, I can only see your messages and I can only be the one that responds to the messages. Myself and of course, Thiari, who is in the back, who is assisting us very much. So that is the reason. I hope you understand. Bella is asking if you can change water to acid. Bella, you may not change water into acid, unfortunately. Okay, so we go to soap. Ladies and gentlemen, soap is falling. Let's look at the taste. Number one, is soap sour or is soap bitter? Soap is actually bitter. Is soap slippery or rough in feel? Soap is slippery, and as a result, soap is seen as a base. Now, I see that someone is asking us, why is it that soap is a base and soap is not an acid? I see this person has not been joining us, but that's fine. In the introduction of this topic that we are currently doing, we spoke about what we call the pH scale. In the pH scale, it starts from 0 all the way to 14. And we said 0 to 6 is your acids that's found on the left. We said 7 is only, for example, water, that's a neutral substance. We said from 8 to 14, that would be your base. So if you're looking at soap, it falls under 10 to 12 on the pH scale. And because it's on 10 to 12, it means it's between the 8 and 14, which are basic substances. I hope I've assisted in explaining your answer. Thank you so much. All right, ladies and gentlemen, let us move. These were corrections from the previous activity. At the end of this lesson, we'll also give you another correction so that we can be able to, of course, do the same as we've done here today. So, what are we doing today, ladies and gentlemen? The first objective of this lesson, we are going to study the periodic table of elements. That is number 1. Number 2, we are going to look at the developer and the year in which the periodic table was developed. Number 3, we are going to look at the arrangement that are found in the periodic table. Let me repeat myself, ladies and gentlemen. Number 1, we are studying the periodic table of elements. That's the first objective. Number 2, we are looking at who developed this periodic table, as well as the year in which this was developed. Number 3, ladies and gentlemen, we are going to look at how the periodic table is actually arranged. So those are the objectives of the lesson. By the end of this lesson, that's what all of us should have learned, and I'm hoping that we are going to achieve that goal. I'm quickly browsing through the chat to see if we've got any questions that need me to respond. I see that we do not have any questions. I will then continue. All right, so questions to think about. Number one, I want you to ask yourselves, what do we mean, or what is the periodic table of elements? Let's think about it. It's obviously a table in the way that that word is actually saying itself. Number two in that question is asking us the when. Ladies and gentlemen, if you've got a phone next to you, if you've got a laptop, you are more than allowed to go and browse through these and possibly respond in the chat box. Remember, now we've got information on the palm of our hands. Number two, what is it that we are speaking about when we are talking about the periodic table of elements? So in essence, what is the importance of the periodic table of elements? Hello, Ranzu. Hello, Amu. Thank you so much for joining us. Number three, how is the periodic table of elements actually arranged? So these are just questions that I want us to think about. These are questions that I want us to guide in terms of what we are actually going to continue and learn here today. Let us move on that slide. Okay, so let's look at the origins or the history of the periodic table of elements. Number one, ladies and gentlemen, the periodic table of elements was developed by someone called Dmitry Mendeleev. Let me repeat that word. His name was Dmitry Mendeleev, and this was in the year 1869. A very long time. Ages and ages ago, ladies and gentlemen. I'm assuming, obviously not even assuming, a lot of us were not even born here. No, we were our parents actually born very long time ago. He was born in 1834, and unfortunately he was passed in 1907. He was a Russian chemist. What is a chemist, ladies and gentlemen? A chemist is someone that studies the properties of matter. Remember when we introduced term 2, we spoke about properties. We said to you, properties are nothing else but how a material or a substance behaves, how it is, how it looks, and therefore we classify it likewise. So he was a chemist. He was born in Russia. His name was Dmitry Mendeleev. He discovered the periodic table in 1869. Now, ladies and gentlemen, this is important. Why? Because if you're studying science, you will often get questions that are asking you, who discovered this, who discovered that, in which year? And therefore, it's important for us to know so that we can be able to respond likewise. Welcome, Mutswedi. I see you are here. I'm happy that you are here joining us here today. Mutswedi is already explaining the periodic table of elements in terms of how it's arranged. Mutswedi, thank you so much. I am very, very impressed. Okay, so let's look at how this periodic table of elements is actually arranged. Ladies and gentlemen, the periodic table of elements is arranged in rows as well as columns. You will see as I'm moving the cursor here, these are rows at the top in blue. They are moving from the left-hand side to the right. I feel that it was important for me to explain this. Often we act as if we understand what rows and columns are, but in a lot of instances, we do not understand. And therefore, us speaking about them in the way that we're talking about them assists us to break those misconceptions and misunderstandings to ensure that we all know what we are talking about and we are all on the same page. So let me repeat myself. The elements of the periodic table are arranged in rows as well as columns according to the properties in terms of the behaviors. And therefore we group them if they are similar, and therefore we differentiate them or separate them from each other if there are some differences or some underlying distinctions amongst each other. So ladies and gentlemen, again, this is a table. I'm simply moving the cursor. At the top in red, those are rows moving from left all the way to right. In green, ladies and gentlemen, going down, meaning up to down, those are what we'd be calling the columns. Again, rows are found at the top of any table. They are at the top left to right. Columns are found going up to down. So basically that and this. So rows, those are rows, and these are columns. I hope we all understand so that we all know what we are talking about. Okay, Nonhlanhla is asking us, why do we need the periodic table of elements? Nonhlanhla, very good question. We need the periodic table of elements, Nonhlanhla, to classify substances in nature, to know what is what. For an example, in the first term, you'll remember, Nonhlanhla, we classified living things. We spoke about animals, we spoke about plants, we spoke about bacteria and all of that. That is important for us to know what is what in the world that we live in. So for those importances, Tyrone, I'm glad that you were given the periodic table of elements. Even if you're not, you can simply Google it and you will find it. Ladies and gentlemen, this is a picture of our chemist who actually developed the periodic table of elements, Dmitry Mendeleev. There you can see him there in the right-hand corner. Okay, so let us continue. The periodic table of elements. So basically, what is it? The periodic table of elements, ladies and gentlemen, is a classification or a grouping system that arranges all elements that make up matter and materials in the world. Again, let me repeat that definition. The periodic table, the periodic table is a classification system that categorizes. What is to categorize? It is to group and separate or arrange things of all the elements that we find in the world according to their similarities and their differences. We'll get into that. But now when we speak about elements, some people are maybe asking, what are elements? Let me see. Okay. Thank you, Nonhlanhla, for acknowledging. I'm glad I could be able to respond and you understand. Okay. So what is an element, ladies and gentlemen? Okay, I see no one is responding, but the definition is found right there on our slide. An element is a single substance that cannot be broken down by any reaction. It already exists in its simplest form. Let me reply. An element is a single substance that cannot be broken down by any chemical reaction. It already exists in its chemical form. For example, oxygen, hydrogen, and gold. So those are examples of what we call elements. They exist in their singularity. They are already in their simplest form. You cannot break them down. It is how they are. However, as we go, we are going to speak about compounds. And therefore, it's also important for us to explain and understand what compounds are. Ladies and gentlemen, compounds are a combination of two or more elements that therefore make a compound. So a compound is something that is made up of two or more elements. I'll make an example. Water is a great example of a compound. And throughout learning about the periodic table, we will be referring to water. The reason for that is because water is made up of hydrogen and oxygen, two hydrogen atoms as well as oxygen. So H2O, if you can think about it, there's water brands that call themselves H2O. Remember, hydrogen is an element. Hydrogen is an element, oxygen is an element. The two combine together and they give us a compound, which is water. But hydrogen alone and oxygen alone are what we call elements. Let me repeat myself. In their singular form, elements are in their simplest form. They cannot be separated. However, compounds are a combination of two or more elements. For an example, water. I'm hoping that you understand what we are saying. Thank you so much, Nonhlanhla. Elements are pure substances. Hence, we are saying they are in their simplest form and cannot be separated. That is good. Figile Shabangu is asking, water is H2O. Thank you so much. That is what I was trying to explain, that water is in fact H2O because water is a compound. It combines hydrogen as well as oxygen. Figile is asking us what happens if you put soap and water. Figile, last week we were studying about mixes or solutions, right? Now, what you are asking me, when you put soap and water together, you are creating a solution. You are creating a solution. Why? Because the soap dissolves in water. What does it mean? It means that the soap particles are absorbed by the water particles, therefore creating what we call a heterogeneous mixture, which is a substance wherein it will be difficult for you to separate because you cannot see what you're trying to dissolve inside the water, which is a solvent. So that is the topic that we've done. Please go on our YouTube page on African Teen Geeks, as well as Facebook, and of course the website to have a look on those explanations that were already done last week. Thank you so much. That is a great question. Now, ladies and gentlemen, when we are studying elements, we will refer to atomic mass, we will refer to atomic number. Now, this content is the content that is done in grade 8. Let me acknowledge that firstly. I cannot therefore teach you about the elements as well as the compounds that are found in the periodic table if I do not speak to the atoms. Again, let me acknowledge the content of us focusing solely on atoms will be done in grade 8 by a lot of us that will be going there, and of course grade 9. But we cannot speak about elements and their atomic number and how many atoms are found there without explaining atoms. And that is why I felt it was important to have a slide and a video on atoms. So what is an atom? Ladies and gentlemen, an atom is a very small basic unit block of matter in which it makes all the elements on Earth. So atoms are small things that combine together and therefore they make anything that we see on the Earth. So basically, if I'm looking at this container of water, it is what we call matter because it's made up of plastic. But before the plastic could be able to combine together, a lot of atoms were combined in making this plastic. So in the basic structure of a hydrogen atom, you would find a proton, which is positively charged. You will find an electron, which is positively charged, which is negatively charged, excuse me. Now they are both 1-1 in terms of their charges. Ladies and gentlemen, I want to show you a video so that can better explain what we are talking about here. We are sitting with 64 participants. Thank you so much for everyone who's joining us for the first time, and those that are coming, we truly appreciate it. Ladies and gentlemen, please bear with me. I want to play this video for yourselves so that you can fully understand what an atom is. Again, I'm acknowledging that atoms is a topic that is done on grade 8. I'm therefore not going to spend much time on it, but I want you to understand and get the gist so that I'm just not speaking about something that you may not understand. So let me share that screen right now. Okay, there we go. Let me open the volume. Okay, it was muted before. Let me enlarge the screen. Let us. We're so tiny that we can only be seen with machines. Now I have a question for you. Do you know the meaning of your name? Very good if you know. If you don't know, ask your parents. But I also know the meaning of my name. It means that which can be cut, that which is uncuttable. Actually, it's a Greek word, which means it is indivisible, which means it can't be divided further or can't be cut further. Let me show you something. Let me ask this man to cut the apple in his hand in half. Now do it again. Please do it again. Keep doing it until you can't cut it any further. Yes, this is the smallest part that you can't cut any further. But it can also be cut under a microscopic machine. So, if you get a part so small which can't be divided further, it is called indivisible. It can be cut further. It is uncuttable. It is an atom. Everything is made out of atoms. This motor, this table, this blackboard, this pen, these fruits, everything. Everything is made up of atoms. Everything is made of molecules, but all molecules are made of atoms. Confused? Look at the blackboard and write any sentence. Good. Now this is the whole sentence. Now circle all the words on your phone. Now let's take a word and circle all the letters of all with some other color. Good. You see, this sentence is made up of words, but words are made up of letters. The letters are the smallest units of a sentence. Similarly, everything is made up of molecules, but molecules are made up of atoms. So atoms are the smallest unit of everything. See, water is made up of water molecules, but water is made of atoms. There are 2 atoms of hydrogen and 1 atom of oxygen in each water molecule. So when atoms join together, they form a molecule. And when molecules join together, they form a thing. So now you understand. Good. So now, friends, now I would show my body. Yes, I would show different parts of my body. There is the nucleus. It is made up of even smaller parts. These are called protons and neutrons. Each of these protons carries a positive electrical charge. Neutrons are equally as heavy as protons, but don't carry any electrical charge. So, the nucleus of an atom is positively charged due to protons. Now, electrons are outside the nucleus. They are orbiting around the nucleus. Electrons carry a negative charge. The total negative charge of electrons is equal to the positive charge of the nucleus. So in total, an atom is neutral. The positive charge of the protons is neutralized by the negative charge All right, ladies and gentlemen, thank you so much. Let us then continue with our lesson. But basically, ladies and gentlemen, all the molecules that we find on Earth are made up of atoms. And we are saying atoms are so small that we cannot see them unless they are combined and bonded together to create something, for an example, water. But hydrogen alone and oxygen alone, it's difficult to see. And atoms are made up of protons as well as neutrons, apologies for that. And then therefore, when they combine together, they give us what we call a molecule. I'm trying to open and share the correct screen so that we can continue. There we go. Okay. And we are back to the PowerPoint. Thank you so much for everybody that was patient enough. This is found on YouTube so that you can actually have a look and study further. So we are saying atoms are made up of protons as well as electrons. Protons are positively charged. Electrons are negatively charged, and combined together, they give us an atom. For an example, you can see the water molecule here on the side, that these are 1, 2 hydrogen atoms, and this oxygen atom combining together to create water, which is what we call H2O. So again, ladies and gentlemen, remember I said this is for interest. This is actually grade 8 and 9 content, but we cannot ignore it because we'll be talking about atomic mass and atomic number. So therefore, we need to tap into that. But also this will benefit us so that when we go into grade 8 and 9, we can be able to therefore be one step ahead. All right, so how is it that the elements in the periodic table are actually arranged? Ladies and gentlemen, firstly, I want us to understand the colors that you are seeing in this periodic element, table of elements, are not the colors that you'll find in all the periodic table of elements that you will actually research or Google and find in school. In some other ones, like this one that I'll put up from a textbook, the color is different, right? If you look on any other site, you'll find that the metals which are always found on the left are not as blue as these ones are. So they might be green, for example, ladies and gentlemen, in this instance, right? So that's what I'm saying, to say the colors that are on the screen right now will not always be the colors that you find in different periodic table of elements, but the elements that are inside will always be the same. Metals, non-metals, and semi-metals will always be the same, but how they are differentiated in terms of color will differ. So let's continue. The blue colors of the elements there on the left are what we call metals, ladies and gentlemen, with the exception of hydrogen. So hydrogen is the only blue one, but it is not a metal. Then the ones that are in the middle, ladies and gentlemen, that are found in yellow are what we call semi-metals, also known as metalloids. Let me repeat myself. The blue part on the left is metals. In the middle, which separates the metals and the non-metals, in yellow on this periodic table of elements, ladies and gentlemen, is what we call semi-metals or metalloids. On the far right-hand side, ladies and gentlemen, colored in pink, is what we call non-metals. So in blue on the right, we have metals, except hydrogen, I repeat. In the middle in yellow is what we call semi-metals or metalloids. Right in pink is what we call non-metals. Ladies and gentlemen, I hope you can hear me. And I hope you understand what I'm saying about this. Bella is asking, in an exam, do we have to know all of them? Bella, no. For the purposes of grade 7, we only need to know the first 20 elements of the periodic table, and that is what we are actually going to be doing, Bella, between tomorrow and Monday. You don't have to know all of them. According to the policy, which is CAPS, you only have to know the first 20. I appreciate your question. Very good question, Bella. Okay, now let's look at the representation of elements of the periodic table. Number one, each element, I saw someone was asking about the element's name, was asking about the atomic number and the symbol. That's where we are touching on right now. Each element has got its own name. I want to use hydrogen as an example. So hydrogen is the name of the element. H is the symbol, if you may, the abbreviation. But again, abbreviation here might be problematic because not all the words, let's for example, not all the words like hydrogen, the symbol will then be H. But for you to understand right now, let us just use that explanation. But again, I'm saying that will not always be the case. So hydrogen is the name of the element, the symbol is H. Hydrogen, according to the periodic table, I'm going back, is number 1. Meaning that it's got how many number of atoms? It's got 1 number of atoms. The atomic number of hydrogen is 1, ladies and gentlemen. I repeat, hydrogen is the name, H is the symbol or the abbreviation. Now that will not always be the case because it's the first one in the periodic table. How many atoms does it have? It's got only 1, and that is the atomic number. I hope you can understand. Devonte is asking if I can go back to the periodic table. I'm going back. Tania, gold is a metal. Thank you so much for that answer. Yes, Figile, at the end of each lesson, we ask people to do an activity. We are going to do that activity in about 10 minutes before this lesson ends. Remember, I said we can find the periodic table of elements in textbooks. Also, when we use our phones or our devices, we can actually Google the periodic table. But as I've emphasized, the colors in terms of differentiating the metals, non-metals and semi-metals will always be different. Mutswedi is saying something there. Mutswedi, you are correct. Helium is number 2 on the periodic table. Therefore, it's got 2 atoms. The symbol for helium is He. We are going to get into that. Thank you, Mutswedi. Okay, ladies and gentlemen, I want us to talk about what we've learned today. What are the takeaway points? Number 1, the periodic table of elements was developed by a chemist called Dmitry Mendeleev in the year 1869. Number 2, the periodic table of elements is a classification system of all the elements of matter and materials that are found in the world according to 3 categories, which we find on the left. Those would be the metals. In the middle, semi-metals or metalloids, or on the right-hand side, those would be the non-metals. The periodic table of elements are arranged, as I've explained, in those 3 different parts. I'm trying to look at the questions. Yes, Ranzu, we'll be learning more about elements in the next lesson. Tomorrow, Monday and Tuesday, we'll be learning more about elements, definitely. Okay, Figile, to answer your question, there is our activity that we need to do today. Number 1, who developed the periodic table of elements? Number 2, in which year were these developed? The slide I just passed is giving you those 2 answers. Number 3, ladies and gentlemen, you will have to research your own periodic table of elements and find each of the following: 2 metals, 2 semi-metals, and 2 non-metals. I will leave that slide for a bit so that people can be able to screenshot it, so that people can be able to write down their questions so that they can do the activity at home today or tomorrow morning before we meet. Or you can, of course, access us on African Teen Geeks and also found on Facebook, found on YouTube, as well as the website. We learned, Mama Khadi, about the human body when we introduced the African Teen Geeks initiative, which is the e-schooling, but we only focused on reproduction. That lesson will be found on YouTube, as I've been trying to explain. Remember, we are following the annual teaching plan as per the Department of Basic Education, as aligned in the CAPS document. So everything that we are doing is there. So unfortunately, we cannot do the human body again because it was done. So we are just simply following that policy document, which tells us what to do and when to do it. Amo, thank you so much. I appreciate that you found this lesson helpful. Thank you so much, Amo. That means a lot. Obaleng, I will go back again just a bit to the periodic table of elements, but as I've said, you can actually Google and research this and you will find these. Lil, I explained that how the periodic table of elements is arranged is always the same, but how it is divided between the metals, non-metals, or semi-metals differs from textbook to textbook or from source to source, the color is not the same. Please don't focus on the color. The color will confuse you. Focus on what I'm going to say right now. The metals are found on the right-hand side. The semi-metals are found in the middle. The non-metals are found on the right. Please focus on that, ladies and gentlemen. That's all you need to know. The color in terms of differentiating those things will always be different. Kiandra, thank you so much. If you found this lesson interesting, I also truly enjoyed this lesson. Let us remember to screenshot and take these questions down so that we can do corrections tomorrow, ladies and gentlemen. Figila, I'm happy to hear that you enjoy the periodic table. A lot of people find it very difficult and they would rather not actually find it as interesting as you do. I really, really appreciate that. Thank you so much. Chanel, yes, we have classes tomorrow as well as on Monday at 3 p.m. Natural Sciences. Please join us again, Bunolo. We enjoyed having you today. Ranzu, I appreciate that. Also, thank you for joining us and thank you for always being positive and being here. Ladies and gentlemen, these are some of the links that we use to create and to make this lesson so that you can be able to be encompassed with different types of sources. Have a look at these yourselves if you want to go through some of the videos and the tables and do some research for yourself. What are we doing tomorrow? Tomorrow we are looking at the properties of metals, semi-metals, as well as non-metals. So basically we're looking at how it is that they are, how they react, and how they differ from each other. That's what we are doing tomorrow. Mutswedi, thank you so much. I also found you helpful. Thank you so much, Ntlantla, as well. Ladies and gentlemen, please follow us on the following hashtags that are on our screen: on Lockdown It's School, on African Teen Geeks, at Izora, ladies and gentlemen, at DBESA, as well as Sasol Foundation and Sasol SA. Hashtag STEM Champions. Ladies and gentlemen, I'm looking forward to joining you tomorrow. My name is Mr. Alex Songo. I truly appreciate having you guys here today. Enjoy the rest of your day. See you tomorrow at 3 p.m. for another installment of Natural Sciences with myself. Thank you and goodbye.